Well, so thank you for the invitation to talk here today. I'm going to, I don't know how many of you know about Lua, or how much each one knows about Lua. In this talk, I will not be very technical, at least most of the talk is not very technical. I will talk more about the motivations for Lua, why people choose Lua, and I'll talk also about Pallene, which is what we are calling a companion language for Lua. I will explain that in the slides. Well, I like this. I think the designing a programming language is not completely unlike this description of how to draw a horse. So you draw two circles, then you draw the legs, you draw the face, you draw the hair. So you put the main components of the language, you give it the character you want for the language, kind of the vision you have for it. And then after that, you add small details to complete the languages. And I think a programming language is exactly like that. I mean, you have the vision, you have some basic ideas, but then you start adding small details. And I think the point of my talk is more or less how we keep adding details and more or less keeping the original character of the language, and what is the original character of Lua, what we try to keep in the language as it evolves. And so exactly Lua now is a language with a lot of small details, but also I'm going, as I said, I'm going to talk about Pallene. Pallene is as I said, it's a companion language for Lua, so it's a kind of an evolution for Lua. It's intended to be used with Lua, so it's supposed in the future to be part of Lua, and still have very few details. But so the first part, I'll talk more about, as I said, about the character. Actually, in the second part too, this talk is mostly about why the language is the way it is, and what we try to keep as the main principles of the language as it evolves and as we develop it. So why Lua? At one description, it could be just yet another scripting language. So in very general terms, for those that don't know, it's just a scripting language, not completely unlike Tico or Perl or Python or JavaScript. So it's a scripting language, but it has quite specific goals that I emphasize here, which is portability, small size, simplicity, and emphasis on scripting. So I'll talk a little about all these points. So first about portability. When we talk about portability, we mean that it runs virtually in any platform with ANSI C compiler. That we will see later also demands small size, because if the language is too big, it just doesn't fit in a lot of platforms. So when we talk about portability, we mean it runs in microwaves, it runs inside keyboards, it runs inside cameras, it runs inside everything, a lot of computers that we do not think as computers. For a few examples, it runs inside some operating systems. Inside the kernel of the operating system, it compiles with all those restrictions that you cannot use floating points, etc. It runs directly on bare metal in some installations, even without an operating system underneath it. So portability means really that it runs with very little, you cannot run Lua with k bytes, for instance. That's too little. But yeah, with half a mega with 500 kilobytes. It's enough, for instance, to have Lua running quite efficiently and quite okay in several machines. The size of the language, this is a graph of the number of lines. This is real lines, and there is logical lines. It's that kind of, I think we count the number of semicolons in the C code. So this evolution of Lua, it started with around 5,000 lines. Now it's near 35, so it grew a lot, but it's still, I mean, it's a very linear growth. This is over a period of almost 93, 30, I lost the count, almost 30 years now. So it is growing. We are trying to keep control of the size of the language. This is a very, very, very strong concern for us to try to keep it not only simple but small, as I said, so it fits it uses little memory outside, but the code itself is also uses very little memory. Simplicity, it's hard to argue. Simplicity, it's something that has, it's not always good too. Sometimes the language can be too simple, but the idea, we use a kind of a proxy for simplicity is the size of the reference manual. The reference manual explains everything. In Lua, we are very religious about the manual. We always say if it's not in the manual, it's not in the language. I mean, people say, oh, how that works? And I tried that, it worked. I say, the manual doesn't say that. You should not use that. So the manual tries to be complete. And this is the spine of the manual that gives you a sense of what you have to read. Of course, the manual, it's not a tutorial. It doesn't aim to be easy to read. It aims to be complete and to have everything. But if you can figure out what is written there, that's all you have to read to know the whole language, the syntax, the semantics, the API with C, which is a very important part of the language, and all the standard libraries, which are very few libraries because of portability. So how we achieve simplicity? The idea, one of the main ideas of Lua, to have very few but powerful mechanisms. So the things we try to avoid restrictions. We try to have smart implementations for things so they are reasonably efficient. And so the main, I think the main mechanisms in Lua that we use that makes the language in terms of semantics, etc. So tables, closures, and coroutines. I'll talk a little about each one. Tables is what in Lua is how in Lua we call associative arrays. In the associative arrays means any value as key, so it's just a map of a value to another value. And that's the only data structure we have in Lua. Arrays are just tables used with integer keys. There is absolutely nothing or almost nothing special about the arrays in the language. Arrays are just completely regular tables that we happen to use in a specific ways. Records are tables with literal literal strings as keys. And everything else in the modules in the language are tables with functions inside that. Objects are tables with function and data inside that. So everything regarding data structures in Lua are represented as tables. As I said, we have a very strong emphasis on putting the when there is complexity, trying to put the complexity in the implementation, so the API and the language keep simple. So as I said, outside a table is completely like an array is just a table. Inside the implementation, for instance, when we resize the table, the language, the implementation recognize that it has a lot of integer keys, or it has integer keys that makes good use of arrays, so it changes the internal representation in internally used. So if you are using a table as an array, it is being represented internally as an array. If you change the use and start using as a sparse array or anything else, then it adapts automatically. So we have arrays in the implementation, but we don't have arrays in the language. Closures, it's the famous first-class anonymous functions with lexicoscoping. That's what Lua has. Now a lot of languages are incorporating that. Lua had that for a long time. And what is, I think, it's a little different in Lua from other scripting languages, from other non-functional languages, that we use closures a lot. I mean, we tend to represent a lot of things in Lua as functions, as anonymous functions. For instance, when we compile a chunk, it's a dynamic language, we have that kind of eval that all dynamic languages have. In Lua, we don't have eval. We had something that's kind of a load that you give a string of code, and it gives you a function that is the code associated with that string, and then you can call. So eval, it's in two steps. First you create the function, and then you call the function, but there is always this idea of the function being present, so you can manipulate the function, you can call it several times, you can even pass arguments and return values from evals. But the idea is that I'll show, even as I told that about, the modules are tables populated with anonymous functions, and even exception handling, it's done using anonymous functions, because one big concern that I'll talk later in Lua is this idea of scripting, that Lua, it's, since the beginning, it was written to be integrated with C, to be used by a host program calling Lua and Lua calling the host program, to have this two-way communication. And so, for instance, exception handling, it should be important to be able to do it, to catch errors in C and raise the error in Lua, or raise the error in C and catch the error in Lua, etc. So, for instance, exception handling, we don't have a try-catch or any syntactical construction for exception. In Lua, instead of that, what we would write like try-catch in other languages, in Lua we have only this special function that is called pcall, this protected call, that calls a function, and if there is any error during the execution of the function, the pcall catches the error and returns an error code. So what would be equivalent to that code would be a pcall. You put an anonymous function there, you use that. The indentation here is on purpose, that the function is there. The end, it's here to give the idea that this is a block, but also the block here is the body of the anonymous function. And so, as I said, this construction, it's not very natural, but it's very good for the API with C, because then the function itself could be a C function, or in C you can do a pcall, you can call Lua in protected mode, so all the errors are protected. And it's the same mechanisms both in Lua, both in C, so it integrates completely for both sides. We joke that Lambda, the ultimate block constructor, we use lambdas a lot for that kind of things. And Lua have coroutines, which is a word that means a lot of similar but not equivalent things. In Lua in particular, coroutines are equivalent to cooperative multithreading. In particular, it means that you have several stacks, one different stack for each coroutine. So you can suspend the execution of a coroutine inside a lot of function calls and then resume the execution. For instance, you can do some I/O operation, and there is something, you detect that it has to wait something, so you can suspend the execution, and then later you can resume. So that's why we call it a cooperative multithreading. We can prove that it's equivalent to one-shot continuations. So we don't have full continuations in Lua, but if you read papers about how continuations are great, you see that most users of continuations actually only need one-shot continuations. One-shot continuations are continuations that you can call only once. You cannot call the continuation more than once. And also coroutines offer continuations in a way that it's much more natural for imperative programming, because it's like threads. I mean, as I said, it's quite similar to multithreading. You just create a coroutine, it's like you create a thread, it has a body. When you resume, it starts executing, and as I said, you can call functions, etc. It can be anywhere, and then it suspends, then it stops execution, you can do whatever you want, and then you resume, it continues executing from where it stops. And scripting, as I said, a lot of people now kind of associate scripting language with dynamic languages, but there is a very big difference in purpose. That the main idea of scripting language, the name scripting came from this idea, is that the program is written in two languages. You have the scripting, and you have what's called the system language. And the idea is that the system language implements the hard parts, usually the complex algorithms, the complex data structures, and the scripting language connects those parts. The name scripting, I think, came from the shell, from Unix, and the idea that shell is exactly a scripting language, and all those Unix programs are the components that you connect, etc., that you manipulate using the scripting language. And Lua has a very, very, very strong emphasis on scripting. Lua, since the beginning, it was implemented as a library. Lua is not a program. There is a program, Lua, but that program is just a small program that uses the library exactly like any other program. So as I said, for instance, when I mentioned exception handling, everything in Lua is written having this API in the library in mind, how it's easy for C to access that, etc., how it's easy to transfer things, etc. And in particular, Lua is very good not only for extending, usually those names are not very standard, but usually extending a scripting language means adding C functions to the language, so you put libraries written in C, and so the main program is written in the scripting language, and you call those libraries in the system language. And embedding is the reverse. For instance, the main program is written in C, and you call the scripting language for other tasks. In games, for instance, because of the I forgot the name of the rate, the frame rate, usually the main loop is in C, and you call Lua, for instance, for each step in the frame rate, you call Lua to perform, to update the characters, etc. So in games, it's very common to use Lua embedded and not extended, but Lua, it's good for both, and it's very common to, of course, you usually have both. I mean, the C calls Lua, and Lua calls C back to do some small stuff, etc. And Lua is so good for scripting that, as I say, that it's not the same scripting and dynamic languages, that Lua has been used, embedded in a lot of other scripting languages. I still, once I was giving a talk in a Python conference, and Python was not in the list, and someone interrupted me to say, oh, we are using Lua to script our Python programs because, for instance, they needed isolation, and Python can, I mean, we needed to offer the user some scripting capabilities, but we didn't want the user to be able to access everything inside the program, and you cannot do that in Python. In Lua, it's easy. You can have different Lua machines, or you can just build a sandbox using Lua standard. I mean, Lua doesn't have sandbox built in, but it has flexibility enough so you can protect parts. You can just offer some functions to be called from the scripting for the user. And so Lua has been used successful, as I said, in a lot of embedded systems. This short list, most people associate Lua with games. Lua has a big niche in games, but it also has a very big niche in embedded systems. As I said, it runs inside the TVs, it runs inside keyboards, and all kinds of equipment. In games, it's also very popular. And now I'll talk a little about Pallene. That, of course, all dynamic languages have the problem, well, all languages have the problem of performance, but in particular, scripting languages are very, usually they are slow compared with static languages. And one of the main mantras of scripting, that idea that you have a scripting language as a system language, is exactly that, oh, if it's slow, rewrite that part, that main algorithm, that main loop, that part that is slow, you rewrite that in C. This is a mantra of scripting, and we usually give this answer for people, oh, this is very slow, so just rewrite that in C. The main problem is that it's easier said than done, because we have two main problems with this idea of rewriting C. There is data mismatch and language mismatch. Data mismatch means that data has to be transferred between the two languages. So you have, for instance, an array or a table, as I say, represented in Lua, and if you want to manipulate that, you have to transfer that. Either you have to copy the whole array into a C array, or you have to do API calls for each access to an element. So it becomes very slow, this data transfer. And so this process sometimes kills any gain that you could have changing the code to C. And the second problem, that is language mismatch, there is big differences between Lua and C. So if you are going to change just 10 or 20 lines of code, it can be easy, but if you have to change something larger, it can be quite complicated. And one of the worst parts is this last point, that sometimes it's hard to predict whether the data mismatch will kill any gain that you can get from changing to C. And so you have an expensive process that you don't know whether it's going to pay off in the end. So it's very hard to decide, oh, okay, I'm going to change that to C, and then you invest some time, you spend some resources doing that, and in the end you realize, oh, it's not worth that, it didn't gain much, or we have to change something else, have to change the architecture, etc. So one solution that people are using a lot for dynamic languages in general, and scripting languages in particular, is just-in-time compilers. And it has some very good points that you, officially at least, you don't change the language, and you can achieve quite good performance, mainly in benchmarks. They are particularly good in benchmark, but they are very good in real programming too. But they have the one point that they're very, very hard to implement. They are hard to port. They compromise portability, and they are hard to maintain. And there is the problem of optimization killers, that most JITs do not optimize the whole language equally, and so people start to know, okay, we shouldn't use that with a JIT, you shouldn't use that, etc. And then you start creating a subset of the language that you hope can be optimized when you are writing code to a JIT. You have a completely different mindset when programming code for JIT and when programming for the not JIT. So it looks like the same language, but when you are actually programming seriously, it becomes almost two different languages. So the idea of Pallene is, sorry, it is that idea at the end. So if we are already almost with two different languages, maybe it would be much simpler to make explicit that you do have two different languages, and they shouldn't be that different, but at least you know that language is one that I can optimize, that other is the other one, and I know and I expect that if I write code for that language, it should be well optimized. It doesn't depend on what version I'm using, or, oh, that trick that I cannot use that or that. So as I said, Pallene, it's a companion language, and it's been designed as I said, to substitute, is a substitute for C. I always change how to use substitute in English. It's to replace C, to be used instead of C as the system counterpart with Lua in scripting architecture. And so we tried, the main idea is to try to reduce both that data mismatch and the language mismatch. The idea of to reduce the language mismatch is this: Pallene is a typed subset of Lua, so everything you write in Pallene except for types should be valid Lua programs, but not everything you write in Lua is a valid Pallene program. So Pallene is a real subset where exactly we eliminate most of the things in Lua that we know that it's inefficient, that most JITs cannot optimize anyway. So we try to, okay, this is kind of C. This is a very simple language for fast tasks like sorting, or to implement some data structures, etc. And Lua is a different language that you have. And the main point also is that to reduce data mismatch, it operates directly on Lua data. So because Lua has a very strong, how I put that, emphasis on this API. It's not like some other scripting languages. You start calling functions inside oh, there is that function. In Lua, you have a very well-defined API. It's very well documented, and always you must access everything through this API. The API gives you good guarantees, but it is a little slow, as I said, for instance, to access, to traverse an array. Each access you have to do an API call, etc. And Pallene, because it is compiled, it ensures that you are accessing the data in the correct way. You are not breaking any invariant, etc. So your code can access data structures, Lua structures directly, and respects, for instance, things concerning the garbage collector and all those details. And it has some ideas from gradual typing that I'm not talking here, but this idea that exactly that it has types and it talks to a language that doesn't have types. But so this is an example, for instance, to a function in Pallene. The only difference from that to Lua is that you put the types in the parameters. If you think about a JIT compiler, the main complexity of a JIT there are two main complexities, actually. The first one is to infer those types. And we think it's much, much easier if you write those types and give that instead of writing a lot of complexity around that to try to infer the types that you intend for the function. And the second, I think that is the worst part of the complexity of a JIT, is that if the type is incorrect, it has to roll back to the interpreter. I mean, JIT ensures that it has the semantic of the original language, so it infers types, it optimizes for those types, but if you call the function again with a wrong type, then it de-optimizes, has to transfer data that is in the registers back to the scripting language representation, etc. And this is also a big source of complexity for JITs. And just adding those types, you eliminate both sorts of complexity, because first you give the type, so it doesn't have to guess, to warm up, doing some executions to try to infer the types. And second, if the type is wrong, it raises an error, and that's it. So it's not only much simpler, but usually it's faster, because this is something that people not always realize, but even when you had a hot path in a program, sometimes the else that you don't use, the complexity of the code there affects the optimization of the fast path. So if the else is just throw an error, is a function that it knows doesn't return, it does not affect the code generation, the register allocation, etc. for the fast path. So the code is like, if it's the wrong type, raise an error, that's it. Otherwise, so the compiler has a much easier task optimizing the code. And the programmers maintaining the code, it's much, much easier to write a compiler for that than to write a JIT. So the design principles, what's the ideas behind Pallene that we will try to keep in the future. So I think one of the main points is that the same selling points from Lua. So it should be portable, it should be simple, it should be small, and of course the idea of scripting is built in the idea of Pallene. It has a very simple type system. It does, as I said, we don't want to type all Lua programs. We want to type what we know can be efficiently compiled. So it's arrays, records, those, for instance, maps, for instance, now it's out of the language. Maps it's slow. If you're really writing something really efficient, you shouldn't be using maps. Another point is what we call good on the borders. This is exactly this on the border between Lua and Pallene. The calls from Pallene to Lua and from Lua to Pallene should be fast. You shouldn't have to pay much to change languages. It has what's called the gradual guarantee, which means that supposedly if you have a Pallene program and remove those type annotations, it should have exactly the same semantics as in Lua, so it's easy for you to see a Pallene program, and if you know Lua, you should know what it does. Of course, it's hard to keep a complete gradual guarantee. There are some things that will change, even sizes of structures, etc. can change, but usually we try to keep as much as possible of that. And we want to use a very simple ahead-of-time compiler. The idea is that we want to compile Pallene, we do compile Pallene to C and ahead of time, because we have all type information, etc. So as I said, the selling points should be portable, should be small, should be simple, and emphasis on scripting. The simple type system, as I said, a lot of people think that the point of dynamic typing, what is expensive in dynamic typing, is checking the types. Actually, checking the type is not that expensive. Usually the tag is next to the data, so when you read the tag, it's already on the cache, or it gets the data in the cache. So reading that is not expensive. The check itself is with a good CPUs now with good jump predictions. Almost always the check is correct. So the price of checking tags, it's very, very small. What is really expensive in dynamic languages is boxing and unboxing, but because when you don't know what is the type of something, you don't know the size, or you still have to need the tag, so you cannot keep in a simple register, you cannot pass as parameters like regular parameters, etc. So the really expensive thing in dynamic language is this thing of boxing and unboxing. So when you give type information, you can, even if you keep the type check, you can run the code assuming all data is unboxed. When you read something outside, that part is boxed. For instance, an array, it is kind of naturally boxed because it has to be in memory. And then when you read that, you check the tag. If the tag is wrong, you raise an error. Otherwise, you automatically unbox that. You don't have to keep the tag anymore. So that's the main source of optimizations when you give types when compiling dynamic languages. And as I said, things that cannot be optimized, it's just out of the language. You don't have, for instance, pattern matching is an example of things that's very difficult to type. You have captures, etc. Each pattern can generate different kinds of answers. And so you have a type any that represents anything, so you can type those stuff in Pallene, but usually it's better just keep that part of the program in Lua. You are not going to optimize that anyway, so just keep in the original language. As I said, it should be good on the borders because you want to translate only the critical parts of the performance. You don't want to translate the whole program. So you shouldn't lose any gain that you got from translating to Pallene, calling Pallene from Lua or calling back Lua from Pallene. And so, for instance, if you change even small functions or just a single function from Lua to Pallene, it should not make the program worse. It's like that. Oh, if you change all that, then you have gains. But if you change gradually, each change does not improve. Only after you do everything, then it's going to improve. And then you realize it didn't, and then you waste a lot of time. And so gradual guaranteed, I talked about that already, so don't need that. And as I said, a simple ahead-of-time compiler. It generates C. It generates C using the same standards we use in Lua to only ANSI C. We are very, very strict about the reference manual of C. We respect everything or almost everything the manual says that C should. It's unbelievable. I don't know how many of you really know C. I mean, how hard is to write portable, really portable code in C. A lot of things you see, oh, that's obvious. You read the manual say you can. That's not only obvious. That's undefined behavior, and so Lua has a kind of very successful story of portability, and we try to generate code following the same rules. And of course, it simplifies a lot the implementation. So these are just some graphs, so just quick big benchmarks. Just the idea, for instance, here we compare with the main comparison here should be the yellow and green, that it's Pallene against LuaJIT. Of course, we don't want Pallene to be faster or even as fast as LuaJIT. we want to be good enough compared with LuaJIT by a fraction of the complexity of the cost. Yes, I forgot to ask whether that includes questions or.
No, that's extra.
So okay, so I'm good. So but also the interesting here is exactly the blue one is exactly if you translate the program to C using the data in Lua, so keeping the API. So as I said, sometimes you can have very good gains, sometimes you have the program that's worse than it was because of this translation. So it's something that those are very small benchmarks. It's not a big deal, but as I said, if you have something more complex and you spend maybe a month or even a week doing that translation and the day later you realize, oh, it's worse than it was, so it's not very good. And Pallene, it's always better than Lua. It's on par with LuaJIT. There is some, of course, it's not as good, but it's much, 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 much simpler and cheaper. And C is just a baseline. If you translate the whole program, everything right in C, all data structures, etc. It's just to have an idea of that. And this is also a nice experiment. It's we got some benchmarks, and the idea of this graph is that you broke the code in 3 parts, sometimes just 3 functions, and here, for instance, means that the 3 parts are written in Lua, and in the top, the 3 parts are written in Pallene. And so the graph, as I said, if you change only one of the functions, and you see that in all cases, you may not have a gain, but you never gets worse if you change just one small function from Lua to Pallene. So it can keep the things at least as good as it was. So it's all that are small experiments just gives an idea of what we are heading to now. And so that is, Lua, as I said, is a language with a lot of details that has very strong niches in games embedded software. The main points that I think are, someone asked me how Lua succeeded, and I think it's because of that, and of course because of luck. Luck is always very important, mainly if you don't have a big company promoting you. And performance is always present concern for dynamic, actually for any language, but particularly for dynamic language. And we are trying to investigate, trying to explore this idea of a companion language as an approach for improving the performance of Lua. That seems compatible, of course, with JIT. It's a LuaJIT. It's very successful. It's very, very good in some uses, but it's not. It doesn't follow the Lua main selling points. For instance, portability. To port LuaJIT is always a big project, and it's not that small, etc. So, and of course, it's completely not simple and almost unmaintainable. So we are trying to do something that, as I said, maybe not as fast, but it's almost as fast, but much simpler to implement, much easier to maintain, and portable. And so, as I said, that is compatible with Lua selling points. That's it.
Okay, thank you. Now we've got time for a few questions. We've also got a quick comment from Ian, who was saying at Sociomantic, he mixed Lua and D to serve ads.
Pardon?
One of the guys in our community, Ian, mixed Lua and D at a company he worked at, Sociomantic, to serve ads on the internet. Yeah, like all the weird usability you were talking about.
Oh,
it's been used with D to serve advertisements.
Oh, okay. But yeah, I should put here embedded in. I should put in that list too.
Yes. Anyway, we've got a question over there.
Is the Pallene compiler completely separate from the Lua compiler?
Yes. Yes, it's completely, the compiler is completely separate. The code it generates, it's intended to, it's completely connected with Lua.
Hi. So I've been touching Lua for probably more than 20 years, always in games. I've worked at Blizzard and even on World of Warcraft a little bit, which might represent the majority of Lua code on Earth. You've made a clear emphasis on interacting with C. That's obviously been there right from the very beginning. Why one-based arrays? How did that happen?
Oh, I should have that written. That there are two kinds of languages.
Yeah.
One language that index from 1.
It's just probably the biggest oddity when interacting with C is that one single detail.
Yeah. So for non-Lua, I didn't emphasize that, but that's almost a giving for real scripting languages. They are intended for non-professional programmers. Usually the one that I really forget to put that emphasis on this idea of scripting, that's not only this distinguish between fast and slow, but also there is sometimes a big big separation between real programmers and scripters. Or I think in the game industry, this is very clear that the people that write games, they are not interested in programming. They're interested in creating the game. So for everybody else, this is sometimes hard for us programmers to understand, but for everybody else in the world, including mathematicians, numbers start with 1. You never see a matrix in any book of mathematics with A00. Everything is A1, A2, etc., etc. A1 is much, much, much more natural. You see kids learning programming and they get everything. Oh, it's okay, it's okay. Then suddenly 0, how you count 3 things, it's like 0. There is this joke in that movie about Germans counting like that, but how you count 0, 1, 2, so that should be 3 because it's 0, 1, 2. This is it's completely unnatural, I mean. It's good for, and what is more funny, this is, for me, it's the extra part, is that there are good reasons for 0 indexing. But most programming languages do 0 indexing because of C. Most languages that are 0-based also have the same syntax of C, etc. A lot of languages inherit a lot of bad things from C. And in C, there is no indexing. C does not index from 0 because C has no, Z has pointer arithmetic. The brackets are just syntactic sugar. There is no bracket operation in C. What you have is pointer arithmetic. So you have offsets, you don't have indices. And then, of course, the first element is offset 0. But then all languages after that don't have pointer arithmetic. They don't have pointers. It's completely abstract, but they kept the 0. And of course, okay, if I'm doing a circular list, then the module arithmetic is a little simpler if I use 0 indices than 1 indices. But for most people in the world, as I said, if you count what's the 1, 2, 3, I remember, I think Dijkstra was a crazy guy. He once decided, I'm writing a paper with the first session was 0. I think he wrote one paper like that and he gave up. I mean, that's...
I get the feeling you might have been asked this question before.
yeah, people always ask that, but for me it's yeah.
I do have a second question.
Yeah, and at the time, it was not that prevalent, the 0 indexing. For instance, most of our users in the beginning were like civil engineers, geologists, and their previous experience were Fortran that index from 1 to, and it's very fast. I mean, it is so good. And it's very mathematical, Fortran. It's nobody asked Fortran why index it from 1 when they started. It was completely natural. And nobody asked C why they index from 0 because they don't.
Okay, so that maybe this is a simpler one. You compared LuaJIT and Pallene. There's a couple of cases where LuaJIT worked out faster. Can you describe why that worked out that way in those cases? What's the...
Oh, that's a good question. Well, it should be faster always. It's unbelievable that it's not.
You say JIT should be faster.
Then C? No.
Well, if Pallene is compiled to C and then hard compiled, why should the JIT ever be faster?
Oh, okay. Pallene is not well because LuaJIT optimizes other stuff. For instance, that it recognizes some constants that are not obviously constants in the program. So it's not only types that the warm up. It optimizes other stuff. But the main point is the data representation. Because you see that usually LuaJIT is faster in things that uses large, for instance, matrices and a lot of data, because of LuaJIT uses that actually has very little to do with LuaJIT, and it has to do that LuaJIT uses the NaN trick. And so it uses half memory than standard Lua for a lot of stuff. So the main thing, the main difference is its memory access, memory throughput, the rate of transfers from memory to the CPU. So it's mostly, Lua could use that in the past when it didn't have 64-bit integers. It did use, actually, that, and so it would eliminate that difference.
What kind of memory management do you use? Do you use a garbage collection, or how do you clean up?
Pardon me?
Do you use garbage collection in a language, or how do you clean up memory?
We use the Lua's garbage collection. As I said, all data is... who asked the question?
Yeah.
Oh, it was you. As I said, we access the Lua data structure, so we use the Lua garbage collector, and as I said, the compiler creates code that takes care of that, and so it keeps, it has the guards necessary for access, etc., to keep the garbage collector happy.
So it's a run, stop the world garbage collector?
Oh, the garbage collector, currently you can choose, there is an incremental garbage collector and a generational garbage collector. The standard now, the default is a generational garbage collector.
Okay.
All right, we got time for this one last question.
So how do you organize and grow the community around the language? It's too ugly if I say I don't. No, we keep, I mean, we have a mailing list. We try to keep people polite on the mailing list. But otherwise, we don't organize much. I think we should organize more. I think I think that the main thing we do is to try to keep the language separated from. One point of Lua is this idea that do it outside of, so that this clear separation from the language and then external libraries, etc. So contributors usually write their libraries and write distributions, etc., but they don't change the language. So this is, I think this is the main.
Okay, and that's question time over. Thank you again, Roberto.
Thank you.